We're almost finished with the application. In this section, we're going to focus on working on the home page, learn about query parameters, and play the audio. We'll start by creating the home page. Let's check it out in our browser. Two sections come with the home page: an introduction and a list of songs uploaded onto the site. The introduction will remain static. I've added it for aesthetic reasons. However, the list of songs will be dynamic. We'll be filtering the list of songs by using infinite scrolling. Infinite scrolling will require we impose limits on how many results are returned by Firebase. It's going to be a little tricky, but we can get the job done. We'll be working on the home component file. Open it in your editor. The first thing we'll do is request the data from Firebase. We're going to request the entire collection. We'll introduce pagination in a future lecture. The goal is to start displaying the list of songs first. In the home component file, we'll need to add the script block to the component with an exported object. We'll give the component a name to help with debugging. We'll give the component the name home. We'll want to request the data when the component is created by using the created_lifecycle function. Define it in the exported object. It will need to be asynchronous because we will be making a request to Firebase for the data. Speaking of Firebase, we'll need to import the songs collection from the Firebase configuration file at the top. We're going to be requesting songs from the database. The songs collection object will help us with that. Inside the created function, call the get function on the collection to initiate the query. This function will return a promise. We'll add the await keyword to handle the promise. We'll assign the value returned by the promise to a variable called snapshots. The get function will perform a get request on the collection. We can chain some functions to filter out what documents are retrieved from the document. However, we're going to start by retrieving all the documents in the collection. The value returned by this promise will be an array of documents. We'll want to push the data from the documents into the component. We currently don't have a way to store the response data in the component. Let's take care of that next. Create the data function in the component. In the object we're returning, we'll create a property called songs. By default, it'll be set to an empty array. We'll push the documents into this array. Back in the created function, we need to loop through the documents to push them in the array. We'll call the forEach function on the snapshots array. We'll pass in an arrow function to handle each iteration. The function is provided with the document for its first parameter. We'll refer to it as document. The document's data will need to be pushed into the array. First, call the push method on the songs data property to push an object into it. There are two things we'll want to store. The first is the document ID. It's a unique value we'll want to store because we'll be looping through the results in the template. We'll need to bind the key attribute to the element we're performing the loop on to prevent issues from occurring. We'll use the ID of the document as the value for the key. We'll add a property called docID. Its value will be the doc.id property. The next thing we'll grab is the data in the document. We can call the doc.data function with the spread operator to merge the properties into the object we're pushing into the array. After storing the songs, we can render the data in the template. In the template, we'll have an ordered list element with some dummy list items. It's surrounded by the comments that say playlist. We're going to remove the dummy list items except for one. We're going to perform a loop on the list we left alone. Before we do, we'll be writing a lot of code in the template. It would be a good idea to outsource some of the template in a separate component. In the Components directory, we'll create a file called songitem.view. We'll scaffold the template and script blocks. We'll give the component the name songitem. The template for this component will be the list item element we have in the home component file. We'll cut the list item element from the home component. After cutting it, paste it into the songitem components template. We want to use this component in the home component. We'll need to register it locally. Back in the home component file, we're going to import the component as app_song_item. The path to the file is @/components/songitem.view. Subsequently, we'll need to define the components property in the home component to register the component. We're going to register the app_song_item component locally. After registering the component, we can use it in the template. We'll load the component where we previously cut the list item, in between the ordered list tags. We can begin to loop through the list of songs on the component. We have two options for approaching this. We can pass down the data to the component. In the songitem component file, we can accept the data from the parent component. When we receive it, we can loop through the data. However, this will not work. It's because Vue does not allow for components to have a loop applied to the root element. Instead, we'll have to approach this problem the second way. We'll apply the loop on the component. In each iteration, we'll pass down the item in the current iteration to the songitem component. This solution is perfectly allowed. Let's look at how we can implement it. On the songitem component, we're going to add the v_for directive to it. The expression will be the following: song in songs. We should bind the key attribute to the song.documentID property. Remember, the key should be something in the object that's unique. The document ID is a unique value in each document. The next thing we'll do is pass down the item in the current iteration to the child component. We want to pass along the song data. We're going to bind a property on the component called song. Its value will be the song reference. We'll switch over to the songitem component. The data from the parent component will need to be accepted if we want to use it. Down below, in the script block, we'll add the props option to the component. The value for this property will be an array of props we'll accept from the parent component. We'll add the song prop we bound to the component. Everything is in place. Time to start wiring everything together. We'll start from the top and work our way down in the template. First, we'll replace the static text for the song title with an expression. The song title is in the anchor tag with the class of composition name. The expression will be the following: song.modifiedName. There isn't a page for viewing a single song. We'll be creating the route and component for this page in a later lecture. For now, we'll leave the link as is. Below the title is the artist's name. Replace the static text for the author's name to the expression song.name. Lastly, the span tags contain the comment count. Replace the static number for the comment count to the expression song.commentCount. We'll leave it at that. We're finished with preparing the home template. Let's test the application by refreshing the home page in the browser. The home page is displaying the results from the query we performed. There's one issue we need to deal with. The pagination is not working. We decided to get the entire collection instead of splitting the result into separate pages. We'll deal with this issue in the next lecture. In this lecture, we're going to add a new feature to the home page called infinite scrolling. Currently, we're displaying the entire set of results from Firebase. This solution is not scalable if we end up having hundreds of songs. The user will experience severe lag the larger the dataset is. It would be wiser to change this behavior by requesting the list of songs in smaller pieces. We can use a technique called infinite scrolling to enable this behavior. Infinite scrolling works by requesting additional data if a user scrolls past a specific location on the page. As long as the user is scrolling, the list will continue to grow. There are a couple of things we need to think of when implementing infinite scrolling. Firstly, we need to decide when to perform a request for more songs. If a user scrolls past a location on the page, we'll want to begin requesting data. This is where things can get tricky. We need to keep track of the last set of records we requested. We don't want to return a list of songs that have already been requested. Secondly, we want to make sure we're not making multiple requests. It can lead to inconsistent results and increase the load on the server. We'll address these issues when we come across them. Let's start by outsourcing the request to a separate function. Open the home component file in your editor. Inside this component, we're requesting the data in the created lifecycle function. We'll be performing a similar request when the user scrolls to the bottom of the page. It would be a good idea to move this code into a method we can call repeatedly. This way, we can reuse it to send requests. Below the created function, we'll add the methods object to the component's options. Inside the methods object, we'll define a method called getSongs. We'll add the async keyword to the function because we'll be performing asynchronous tasks. Next, we'll cut and paste the contents of the created lifecycle function to the getSongs function. This function will need to be called from the created lifecycle function. We want to make sure we're making a request for the list of songs when the user first lands on the page. We'll get the same result we had before. The main difference is that we're outsourcing the request to a method we can recall. Great. The next thing we'll work on is detecting when the user scrolls the page. We want to request more data when the user has scrolled to the bottom of the page. After calling the getSongs function in the created lifecycle hook, we'll call the window.addEventListener function. The name of the event we want to listen to is called scroll. The scroll event is emitted whenever the user scrolls. We're listening for this event on the window object. If this event is emitted, we'll run a function called this.handleScroll. We have the option of using an anonymous function. However, we want to remove the event, otherwise we'll experience memory leak issues. First, before we remove the event listener, we'll define this function in the methods object. This function will be responsible for checking the current scroll position of the page. We'll be writing the logic in a moment. Let's remove the event listener if the user navigates away from the page. Components are unmounted if the user navigates to a different page. In the Components options, we'll define the beforeUnmountLifecycle function. The beforeUnmount function is called before the component is unmounted. We're using this lifecycle function because we want to remove the event listener. We could have used the unmounted lifecycle function, but that can cause issues. We need to reference the handleScroll function if we want to remove an event listener. We won't be able to if the component is already unmounted. In the function, we'll call the window.removeEventListener function. We'll pass in the same values we used in the created lifecycle function. Removing the event listener is always an important step if you're working with the event system outside of Vue. We can move on to handling the scroll event. We're going to need some information about the user's browser. In this image, the purple box represents the entire page. The green box represents the viewable area in the browser. There are three properties we're going to need to check if the user is scrolled to the bottom of the page. The first property is called offset height. This property contains the height of the entire page. For this example, let's assume the height of the document is 2000 pixels. The second property is called inner height. This property contains the height of the viewable area in the browser. It's how much of the page the user is able to see. For this example, let's assume the height of the viewable area is 600 pixels. The last property is called scroll top. This property contains the distance from the top of the page to the top of the viewable area. In this example, it's clear the user is at the bottom of the page. This will mean the scroll top property should be 1400 pixels. Here's what we'll do. We'll add the inner height and scroll top properties together. If sum is equal to the offset height property value, we'll send a request for more songs. We'll be working in the handle scroll function. We're going to destructure the document.document element object. This object will contain two of the properties we need. They're the scroll top and offset height properties. Next, we'll destructure the window object. We'll grab the inner height property from it. It's not necessary to destructure the properties. I recommend it for readability. The next thing we'll do is check if the scroll top and inner height properties are equal to the offset height property. We'll declare a variable called bottom of window. Its value will be the following: math.round scroll top plus inner height equals offset height. We're wrapping the scroll top property with the math function. This property may have decimal values. We want to be dealing with whole numbers when making the comparison because the inner height property will always be a whole number. The value of this variable will be a Boolean value. Below the variables, we'll create a conditional statement. We're going to check if the bottom of window variable is truthy. If it is, we'll log a message in the console. This function we've written will be able to tell our component to request more data if the user scrolls to the very bottom of the page. If we did everything right, we should be able to see the message logged in the console. Let's view the home page in the browser. If I scroll to the bottom of the page, we'll find the message we logged in the console. This message verifies we're able to detect when the user has scrolled to the bottom of the page. We can proceed to make a request. We'll take care of this in the next lecture. In this lecture, we're going to implement infinite scrolling. Now that we can detect that a user has scrolled to the bottom of the page, we can initiate a request. We'll be working in the handle scroll function we defined in the home component file. We'll update the conditional block to call the getSongs function if the condition is true. We can move on to updating the request in the getSongs function. Currently, we're requesting the entire dataset from Firebase. The problem with this function is that we're not limiting how much data we're requesting. We don't need to request the entire dataset since we're going to add infinite scrolling. We'll modify the query we're performing in this function. Before we call the get function, we're going to chain a function called limit. The limit function will limit how many results are returned by the API. It has one argument for how many results should be returned. We're going to be using the limit function a few times in our component. It would be a good idea to store how many results per page we want in the data function. We'll add a property called max per page. We'll set it to 3. We're using a low number because we want to be able to test infinite scrolling. We don't have a lot of songs uploaded at the moment. After we're finished with this lecture, we'll bump the number to a more reasonable value. Back in the getSongs function, we'll pass the max per page data property to the limit function. This query will tell Firebase to retrieve the first 3 results from the database. There are additional adjustments we'll need to make. The goal is to grab the next batch of results. We can get the next batch by telling Firebase about the last document we requested. By telling it about the last document, It'll start searching for more documents starting from the last document. Let's write the code to understand better how this works. We'll chain the start after function before the limit function. We're telling Firebase to start looking for documents after a specific document. You can imagine it like telling JavaScript to return items in an array after a specific index. The start after function has one argument. It's the document it should start at. At the moment, we don't have the last document. We'll make a query for it. Above the query, we'll declare a variable called lastDocument. Its value will be the songsCollection.document function with the await keyword. Next, we'll pass in the following value: this.songs, this.songs.length -1.document ID. Lastly, we'll chain the get function. Let me break down what's happening. The start after function requires we pass in a snapshot of the document it should start from. We don't have the snapshot, so we're performing a query for it by calling the document function. We're passing in the ID of the last object in the songs array. The query we've written should return a snapshot of the last document in the array. We're initiating the query with the get function. We'll pass in the last document variable into the start after function. There is one caveat with using this function. We are required to set the order. Firebase will automatically sort the documents in random order. The start after function doesn't like that. It wants us to order the documents before retrieving the results. We can order the results by chaining a function called orderBy at the beginning of the chain. We can use this function to order the results by a specific property in the document. We'll use the modified name property to sort the results. This query will return the next 3 songs in the database. It'll always start the search after the last set of documents. However, that's a problem. In the query, we're using the start after function to instruct Firestore where to begin the search. It'll use the document object we passed into it. If the user is visiting the page for the first time, the object we're passing in will be an empty object. This will break the query. We can't grab the last document until we make a query, and we can't make a query until we have a document to provide it with. We can resolve this issue by creating 2 queries. We'll wrap this query with a conditional statement. The condition we'll use will check the length property on the songs data property. The songs data property will initially be an array. If there are items in the array, it's safe to assume we have a document object we can use in the query. If this ends up not being the case, we'll create an else block with the same query. We'll remove the start after function from the query. This query will get the first 3 songs it finds. It'll always be used for the initial request. If the user scrolls down, the query in the first conditional block will be used because the songs array will have been populated with some songs. We'll need to move the snapshots variable declaration above the chain of conditional statements. We won't be able to use the variable if it's declared in a conditional block. We're almost finished. There's one last thing we need to consider. It's possible the user may trigger the request multiple times while a previous request is still pending. If we don't account for this scenario, it could lead to inconsistent results. We can fix this problem by keeping track of requests. In the data function, we'll create a property called pending request. Its initial value will be false. Let's go back to the getSongs function. At the top of the function, we'll create a conditional statement that'll check if this property is set to true. If it is, we'll return the function. If this property is set to true, we'll stop further requests from running. It'll tell our component we already have a request for songs being made. We'll need to toggle this property in our function. After the conditional statement, we'll set this property to true. Then, at the end of the function, we'll set it to false. We're finished. Let's try testing the application. In the browser, try refreshing the page. The page should be able to display a set of results without us doing anything. I recommend opening the console to check if there are errors. We won't see errors in the console. So far, so good. Let's scroll to the bottom of the page. After doing so, we'll be presented with more songs. We've successfully created an infinite scrolling page. We'll update the max per page property. We already know that infinite scrolling works. We can bump this number to a more reasonable number. We'll set this property to 25. Let's switch back to the browser. If I were to attempt to force the query after we've gotten the full list of songs, I'd be blocked from doing so. We've successfully created an infinite scrolling feature on the home page. In this lecture, we're going to create a route for individual song pages. This is where route parameters will come in handy. We want to be able to store the ID in the URL. The router can store and retrieve the values in the URL if we need to use them in the application. In the resource section of this lecture, I provide a link to the Dynamic Route Matchmaking documentation page. You will learn about how path parameters work in the View router in detail. One part of the documentation page that I want you to look at is this example table. In a nutshell, this is how dynamic paths work. You can set dynamic segments in a path by adding a colon before the name. The router will pick up on this. It'll allow for any value to be used for this segment. In the second column are examples of paths that match the route. If there's a match, the router will assign the dynamic segments to the route.params object. The third column will show what the object will look like. The name of the key is the name you passed in after the colon in the dynamic segment of the path. The value would be what was inputted in the segment. There's a second example showing how you would create multiple dynamic segments. Let's begin creating our first dynamic route. In your editor, open the router file. We'll register the record first. In the routes array, add a new object. We're going to add it below the other routes. We're going to assign the route the name song. We'll set the path property to /song/:ID. The colon is very important. That'll tell the router that the segment can be dynamic. We're going to give the dynamic segment the name of ID. We're going to assign this to a component called song. The component directory currently doesn't exist. Let's create it inside the views directory. The name of the file will be song.view. Next, we can import the component into the router file. The path to the component is @/views/song.view. We're going to test this in a moment. First, let's see if we can retrieve the dynamic path. Switch to the component we created. Inside it, we'll scaffold the template and script blocks. The component should have a name. We'll assign the name property in the component to song. Next, we'll render the ID in the path. Inside the template block, add a pair of div tags. Inside of the div tags, add the expression route.params.id. The params object will hold the dynamic segments in the route. From this, we can access the values by the names we assigned in the path property. We're grabbing the ID in this instance. Let's test the route in the browser. Inside the address bar, type in the path song/. The value for the ID can be anything. It can be a number or random gibberish. It should work either way. We're not enforcing a specific type of data. After visiting the path, we'll see the ID get outputted. It should be the same value you inputted into the URL. The View router was conveniently able to extract the value from the URL and place it inside an object. Let's test to see what happens if we don't input anything in the segment. We get redirected to the home page. This is because of the wildcard route we created earlier. The router couldn't find a match because we didn't provide the dynamic segments. It doesn't consider an empty value valid. Therefore, it won't load the component. It will not check for matches. We created the wildcard route to catch routes that didn't match the URL in the address bar. We programmed it to redirect the user to the home page. That works in our favor because we don't want to display an empty page if an ID wasn't provided. We're finished with creating the dynamic route. In the next lecture, we're going to create the template, grab the song data, and render it onto the page. In this lecture, we're going to do two things. First, we'll create links for visiting individual songs. Secondly, we'll create the template for the song record we registered in the previous lecture. At the moment, there isn't a way to access an individual song unless you directly visit it. We'll start things off by making the links work. We're already looping through the songs in the template. Inside it, there's a link we skipped over. We'll want to link this to the song in the current iteration. We can use the router link component to generate a dynamic link. Replace this with the router link component. The href attribute will need to be replaced with the to property. We'll bind the property so that we can pass in an object to create the correct link based on the name. In the object, add the name property. Set it to song. This value is the name we assigned to the record. Unlike other routes, we need to provide the ID path parameter. In the previous lecture, we saw what happens if we exclude the ID. The View router will not recognize that as a valid path. It'll redirect the user back to the home page. We must provide an ID. If the route has dynamic parameters, then we can add the params property to the object. The params property can be used to add dynamic parameters to the generated URL. It's an object where each key value pair can be used for the dynamic segments in your path. There's one dynamic segment for the record, which we named ID. We'll add the ID parameter. Set this to the song.id property. The router will be able to generate a link to the song based on the data provided. It'll be able to replace the dynamic segment we have in the path with the ID we're passing in. It's important the property name in the params object matches the name we assigned to the segment. That should take care of it. Let's try testing the links on the home page. After clicking the link, we're correctly redirected to the page for the song. The ID parameter was replaced with the actual ID. We can even see the ID parameter outputted onto the page. That verifies that we correctly created a link. Let's work on the template next. In another tab, I have the song.html static template opened. It's a fairly basic template. We can break this down into two sections. We have the header and comments sections. We'll tackle them individually. First things first, we'll need to move the template from the static HTML file to the component. Open the song.html template in your editor. The sections have comments above them saying music header, form, and comments. The first section holds the header of the page. The second section holds the comments. We'll need both for the page. Copy both sections and paste them into the song component template block. When you're pasting them over, completely replace the div tag with the expression we had in the component. We're finished with moving the template. The next thing we'll take care of is loading the song data. we'll need to grab the data related to the song. We're going to use it to help us render the template for the component. This will require the Songs Collection object from the Firebase configuration file. In the script block, import it into the component. The path is @/includes/Firebase. We're going to need it to request the song data from Firebase. We'll make the request when the component is created. We can do that by defining the created_lifecycle function in the component. It will be asynchronous because we're making a request to the database. Be sure to add the async keyword to take advantage of the ES 2017 feature. We can query the database for a document by using the document function. Inside the function, we'll call the document function on the Songs Collection object. The document function will retrieve a document by its ID. The ID of the document can be found inside the path parameters. Luckily, we know how to retrieve the value from the path. The ID can be accessed via the this.route.params object. Pass this into the function. The ID is assigned under the name ID. Lastly, we'll chain the get function. This function will return a document snapshot. We'll store the snapshot in a variable called docSnapshot. This task is asynchronous. We'll add the await keyword before the function. It's been a while since we've made a request to the database with the document function. We could have used the where function like we've been doing so far. The difference is the where function offers more flexibility. It's capable of returning multiple documents, whereas the document function can retrieve a single document by its ID. The document function is more than suitable for this task. If you decide to use a different value for the path parameter, you would need to use the where function to retrieve the document data for the page. It's something to keep in mind. Moving forward, we'll need to store the result in our component. We'll store it as component data. It isn't necessary to store it inside the state, but that's always an option if that's what you want to do. In the component, define the data function with an object being returned. We're going to add one property called songs. It'll be an empty object by default. We'll assign the response data to this data property. Back in the created_lifecycle function, update the song data property to the value returned by the docSnapshot.data function. We won't store the ID because it's already in the path parameter. We have a way to access it. We're almost finished. It's possible that the user may visit a song that doesn't exist or did exist but was removed from the database for one reason or another. Firebase does not throw an error if it can't find a document. It'll continue to return a snapshot. We can check if a document exists by checking the exists property in the snapshot. After the snapshot variable definition, we'll add a conditional block. The condition will check if the docSnapshot.exists property is false. This property is present in the snapshot regardless if the document exists. We can use it to check if the document is in the collection. If it turns out that it doesn't exist, we'll want to redirect the user away from the page. Inside the conditional block, call the this.router.push method. We'll pass in an object so that we can redirect the user based on the name. In the object, we'll set the name property to home. Lastly, in the block, we'll return the function to prevent it from running further. That should take care of making sure that the page doesn't get loaded when the song is invalid. Let's update the template to display the song data. We copied over two sections from the static template. The first section we have in the template is called Music Header. We'll work on this first. Nested deep inside the section are two div tags. They have a comment above them that says Song Info. In the first div tag, replace the static text with the expression song.modifiedName. Next, replace the static text inside the second div tag with the expression song.genre. These are the keys we gave each song object when we inserted them into the database. As a reminder, you should be using the modified name property instead of the original name property. The modified name is the property that gets updated in case the user wants to update the name of the song. The original name property is what stores the original name of the MP3 file when it was uploaded. Let's check if everything works. In your browser, view a song. Everything is rendering without a problem. The console and the developer tools hasn't produced errors, which is a good sign. Let's test if the redirect works. Inside the address bar, change the ID to something completely random. We're redirected to the home page. Perfect. We're finished with the basics of the template. In the next few lectures, we'll complete the template by working on the comments. We're going to submit the comment and store it in the database. I've outlined some of the steps we'll be taking to complete the comment section. It's a process you will be familiar with at this point. The first 3 steps are what we'll be doing in this lecture. First, we'll validate the comment. The comment will be required with a minimum character length of 3. After validating the comment, it'll be submitted to the database for storage. Lastly, the input will be cleared in case the user wants to submit another comment. In this lecture, we're focused on validating the comment. If you want, go ahead with doing this on your own as a challenge. I'll provide the solution in just a moment. Pause the video and good luck. Welcome back. If you were able to complete the form on your own, then that's great. If not, that's fine as well. Let's walk through it together. We'll work on adding validation to the form. You can find the form in the second section element. The form comprises a text area element for the input and a button to submit the data. There's a drop-down for sorting the comments below the form, but we'll ignore this for another lecture. It serves another purpose. It's not going to be submitted with the data. It won't affect the form submission itself. You can safely ignore it. We're going to convert the text area element to a field component. By default, the field component will generate an input element. We'll need to override this behavior if we want to continue rendering a text area element. We can override the name of the tag by setting the as property to text area. This will validate the input. The field component will work with any of the HTML form input elements. This includes the text area element. We can apply the same rules and properties as we did before. We'll add one more property called name. This property's value should be a unique identifier for the field. We'll set this to comment. Next, we'll add some rules to the comment. The rules we'll be using will be the ones I mentioned at the very beginning. We're going to outsource the rules to a different object. We won't apply them directly to the field component. On the form element, we're going to convert this into a vForm component. We're doing this because we want to use the validation schema property on the component. This property will allow us to enforce rules on the fields inside it. We'll set this property to an object called schema. This object doesn't exist in the component. Let's create it in the components option. Down below, we'll add the schema object. We have one field we want to validate, which is the comment field. The rules for the comment field will be the following. Required min3. After validating the comment field, we'll output an error if the rules get broken. It's important to provide feedback to the user if their comment is invalid. We'll go back to the comment form in the template. Below the field component, we'll add the error message component. Next, add the text red 600 class to change the color to red. Lastly, we'll set the name attribute to comment. We're finished with validating the field. We'll continue with the comment form in the next lecture. In this lecture, we're going to start prepping the form. We want to provide feedback to the user to let them know the status of their submission. We'll continue working in the same component we worked on in the last lecture. The first thing we'll do is listen for the submission. On the form component, listen to the submit event. The name of the function that we'll want to run will be called add comment. The function will need to be defined. In the methods object, define the add comment function with the async keyword. We're making the function asynchronous because we'll be dealing with asynchronous tasks. The comment will be stored in the database. Database operations are mostly asynchronous tasks. The function will be supplied with one argument called values. This argument will represent the values in the fields we have in the form. We'll add it in. Inside the function, we're going to start by adding the alert boxes. The purpose of the alert box is to tell the user their submission is in progress. It'll also let them know if their submission was a success or failure. Inside the data function, we'll define the properties for controlling the alert box. Add the property comment in submission with an initial value of false. We're going to disable the button with this property if the comment is currently in submission. By default, the value will be false, allowing the user to submit a comment. Next, create a property called comment show alert with an initial value of false. This property will be used to toggle the alert box. By default, it'll be hidden from view. Afterward, create the comment alert variant property with an initial value of BGBlue 500. That's for the color of the alert box. Lastly, we'll add a property called comment alert message. The value for this property will be the following. Please wait, your comment is being submitted. With the data properties ready, we can hook them up to the template. Scroll to the form component. We'll add a div tag with the following classes: text white, text center, font bold, P4, MB4. We'll toggle the visibility of the alert by adding the vIf directive. The condition will be the comment show alert property. After toggling the visibility, we'll start working on changing the color. We'll bind the class attribute to the comment alert variant property. For the inner content, we can add the expression comment alert message. The last modification to the template will be toggling the button submissions disable attribute. We don't want users to submit the form again while a comment is inserted into the database. That could cause accidental duplicate comments. Bind the disabled attribute to the button element in the form. Bind it to the comment in submission property. The template and data properties are ready. The last thing we need to do is to handle the logic in the function. We're going to do a couple of things in the function. First, we're going to reset the properties in the component in case they're submitting multiple comments. The user should know that the process for submitting their comment has begun. Set the comment in submission and comment show alert data properties to true. The form submission button will be disabled. The alert box will appear in front of the user. The variant and message will need to be reset in case the user has attempted to submit the comment form multiple times. Reset them to their original values in the component. We can move on to inserting the comment into the database. We'll start this task in the next lecture. In this lecture, we're going to finish the form by inserting the comment into the database. One thing to keep in mind, We aren't validating the form in the function because this function will not be called if the field is invalid. VValidate will force validation on the fields before running our function. We're going to continue working in the song component file. In the function, we'll create a variable called comment. The comment variable will be an object. It'll hold the data we'd like to store in the database. There are a couple of properties that we'll want to store. The first is the comment itself. We'll add a property called content. It'll be sent to values.comment. The next property we'll want to add is the date. In the template, we have the option of sorting through the comment from newest to oldest or oldest to newest. We need to store the date if we want to sort the comments based on the time they were posted. We'll call the property datePosted. It'll be set to newDate.toString. We're calling the toString function because Firebase can't store a date object in its database. It would be an invalid value. To get around this, we can convert the date to a string. When we retrieve the comments, we will revert the date back to a date object. You'll see how that's done in the next lecture. For now, storing it as a string will suffice. Up next, we'll store the song ID. Create a property called SID. Set it to this.route.params.id. This property will help us associate the comment with the song. Afterward, we want to store the name of the user who submitted the comment. We can retrieve their name by importing the authentication object from the Firebase configuration file. At the top of the block, add it to the list of imports. Back in the comment object we created in the function, we can add a property called name. We'll set it to auth.currentUser.displayName. The current user object holds information about the user currently logged in. There's no guarantee that this will hold the information we need because anyone can submit a comment. We'll need to hide the form if the user is not logged in. This is something we'll take care of in a moment. There's one last piece of information we'll want to store. The next property we're going to create is the UID. We'll set this property to auth.currentUser.UID. We're storing the ID of the user as an extra precaution. Generally, you will want to store the ID to help identify who submitted the comment. We're already storing the name, but it's a value that can be changed at any moment. The ID is what's unique to each user. It'll remain constant. We're finished with the object. After creating the object, we'll make a request to the database to store the data. Here's the thing. We don't have a collection for comments. We'll need to create one if we want to add some to the database. In your browser, navigate to the database in the Firebase console. In the first column, we can create a collection. Click on the Start Collection button. It'll ask us for an ID for the collection. We'll call it Comments. Next, it'll ask us to insert a document. We'll delete the document after creating it. Feel free to add in random gibberish. After creating the collection, we'll delete the document. Select the document in the second column. In the third column, we can delete the comment at the top right corner. The collection is ready. We can interact with it by using the Firebase SDK. We created collection objects in the Firebase configuration file to prevent us from calling the collection function multiple times. We'll do the same for the comments collection. Open the Firebase configuration file in your editor. Below the collection variables, create a variable called comments collection. Its value will be the object returned by the db.collection function. This function requires the name of the collection we'd like to work with. We'll pass in the name comments. Lastly, export the comments collection object with the other exports. Switching back to the song component, we can add the comments collection to the list of imports. We can proceed to push a new document into the collection. Back in the function we were working with, after creating the comment variable, call the commentsCollection.add function. We're using the add function in this scenario. It isn't necessary to assign a custom ID to the document. We'll let Firebase handle setting the ID. We'll pass the comment object to the function. In addition, we'll add the await keyword because this is a promise. After the request has been made, we'll want to let the user know their comment was added. Let's handle this quickly. After the comment is inserted in the database, set the InSubmission property to false. That should enable submission again. Change the variant to BGGreen500. Lastly, the message will be changed to the following: comment added. The last step is to reset the comment. It's going to be a little tricky because the comment field isn't bound to a property in our component with the vModel directive. Luckily, vValidate passes on a set of functions to our submission handler for the second argument. In the add comment arguments, the second argument is optional. We can accept an argument called context. The context object contains methods and properties about our form. We can use it to reset the form. We're only interested in the reset form function. We'll destructure the second argument for the reset form function. At the bottom of the function, we're going to call the reset form function. The reset form function will reset the values in the form to their original values. The comment field was originally empty. We should receive an empty field after a successful submission. We've written a lot of code. Let's verify that everything is working. In the browser, make sure you're logged into the app before testing the comment form. Try submitting the form without filling out the field. vValidate will throw an error at us. This error proves the validation works as expected. Next, let's submit an actual comment. After a few moments have passed, the alert will tell us that the comment was added. The comment input was cleared after a successful submission. We can't verify it on the application yet, so let's go to the database console to check if it was added. A new document will appear in the comments collection. If we inspect it, we'll find the comment we made. The other properties should be there as well with their respective values. We've successfully added a comment. There's one last thing we need to do. Anyone can submit a comment. This includes users who aren't logged in. We want to limit comment submission to logged in users only. In the application, I can log out, but the form will still be visible. This is a problem because we don't want anonymous comment submissions. We can fix this by mapping the user logged in state property to the component. It can be used to toggle the form's visibility. Back in the editor, add an import statement for the map state function. Import it from the Pinia module. The map state function will help us with mapping the state to the computed property. Next, import the user store. In the component, add the computed object to it. Inside the computed object, call the mapState function with the spread operator. Let's pass in the user store as the first argument. This function accepts an array of state properties we'd like to map. We'll map the user logged in state property for verifying if the user is logged in. We can now use the state property for toggling the form's visibility. Search for the form element in the template block. We'll add the VF directive to it. The value for this will be the user logged in state property we mapped. If the user is logged in, we'll show the form. Otherwise, hide it. Going back to the browser, you will find that the form no longer appears. Great, we can move on to displaying the comments. Before proceeding on to the next lecture, I recommend logging into the application again. In this lecture, we're going to finalize the comments section by performing the last 3 steps on this list. The 4th step is retrieving the comments when the page loads. The 5th step is to load the comments again if the user submits the form. Lastly, the 6th step is being able to sort the comments. Before getting started, I recommend you submit a few comments to a song. This will help you test the sorting feature. We're going to continue working in the song component file. We want to grab the comments when the component gets loaded, but after a song has been found. Comments won't exist if the song is invalid to begin with. We'll perform the request after the conditional statement in the created_lifecycle function. We're going to call a function called getComments. We could add the logic for retrieving the comments in the created_lifecycle function. However, it's probably best to outsource it into its own function because we already know ahead of time there will be 2 different situations where we'll want to grab comments. The first is when the component is first loaded. The second is when a comment is submitted. It makes sense to outsource the code into a separate function. We'll define the getComments function inside the methods object with the async keyword. Requests are asynchronous, hence the async keyword. We'll make a request for comments right away. We're looking to request multiple comments. The where function on the collection will work in this case. Inside the function, call the commentsCollection.where function with the await keyword. The value returned will be assigned to a variable called snapshots. The where function will be used to help us retrieve the commands related to the song. We stored the ID of the song in a property called SID. Pass this as the first argument to the where function. The second argument will be ==. Lastly, the third argument will be the this.route.params.id property. We're using the ID in the route because we didn't store it in the component. The next thing we'll do is chain the get function to instruct Firebase to initiate the query. We'll loop through the snapshots array to push the data into an array. Currently, there isn't a property for storing comments. Let's define one for that. In the component, create a data property called comments. It'll be an empty array. Back in the getComments function, after the request, we'll reset the comments array to an empty array. We're resetting the comments to make sure we don't have duplicate comments. The request we're making in the function will return every comment. After resetting the array, we can push the documents into the comments array. Call the forEach function on the snapshots array. This function will accept a callback function, which is provided the current document in the iteration. In the function, we'll call the push method on the comments data property. There are 2 properties we'll push into the object. The first is the ID of the comment. We'll create a property called docID. Set it to doc.id. Next, we'll push the data. The data can be accessed by calling the data function on the document parameter. We'll use the spread operator because this will return an object of properties. We want to merge it with the object we're pushing into the array. We're finished with requesting the data and storing it in the component. The next step is to begin looping through the data in the template. In the template, search for a comment that says comments. It can be found under the form. We're going to find an unordered list element. There's a list of dummy comments. We're going to remove every list item element except the first one. we're going to use the list item we left alone as a template. Apply the v-for directive to the list item. The value for the directive will be the following: comment in comments. The key attribute will need to be bound to the comment.docID property. From here, we can replace the static text with its respective expression. Inside the div tag with the class font bold, replace the static text inside with the expression comment.name. Next, below it, there will be a time tag with the class timePublished. Replace the static text with the expression comment.datePosted. Lastly, there will be a pair of paragraph tags inside the list item. Replace the static text with the expression comment.content. We're using the names we gave the properties to access the proper values in the database. You can always check the database to check which names you gave for the values. Let's test if the comments are working. Save your changes. Then, we'll view a songs page in the browser. After a few moments, the comments will appear. If you submitted a few comments, they will be looped through. We've completed step 4. The next step is to load the comments again when a new comment is submitted. We'll take care of this step in the next lecture. In this lecture, we're going to reload the comments if a new comment was submitted. Luckily, we've taken care of a lot of the groundwork already. We don't need to rewrite the code for retrieving the comments. We've outsourced the logic into a separate function. All we have to do now is call it. Back in the editor, scroll to the Add Comments function. Towards the very end, before we update the alert and clear the input, call the Get Comments function. That's all we need to do. Let's give things a test. Back on the browser, try submitting a comment. You will need to be logged in to do so. Once you're logged in, submit a comment. After the comment has been submitted, it appears below the list of comments. Excellent! We can move on to the final step, which is to sort the comments based on their date. We have a drop-down that allows us to toggle the comment sorting. By default, we want the comments to be sorted from latest to oldest. This is the perfect opportunity to use a computed property. We'll create a computed property where it'll return the comments sorted. Switch back to the editor. Under the map_state function in the computed object, define a computed property called sortedComments. The sortedComments computed property will return the comments array sorted. We can sort the array by using the sort function. Inside the property, return the this.comments.sort function. We'll get an error by ESLint. If we were to hover over the line, it would tell us that there's an unexpected side effect. It's very vague, but there's a good reason for this error. The sort array function will change the array it's being called on. Computed properties may use data properties, but they shouldn't change them, at least directly. This is why we're getting an error. Data properties must not be changed in the function for a computed property. This is a problem because we need to call the sort method to sort the array. There's a simple trick to circumvent this dilemma. Before calling the sort method, we'll call the slice method. The slice method returns a brand new array based on the old array. You can use it to extract specific items in the array. It's important we make a distinction between the slice and sort methods. The slice method will return a new array, whereas the sort method will directly affect the array it's called on. This is why ESLint isn't throwing an error anymore. We're creating a copy of the original array and sorting through it. We can proceed to sort through the array. The sort function does exactly what it sounds like it does. It'll sort through an array. We have the option of passing in a function to have more control over how items in the array are sorted. We'll want to do that since we want to sort the objects based on the date the comment was posted. Pass in an arrow function. The function will provide us with two parameters, which we'll call a and b. Both parameters are objects from the array where we can make a comparison between them. Before making the comparison, we first want to check if the ordering should be ascending or descending. Currently, we don't know because we aren't storing the sorting order. We'll create a data property for keeping track of the direction the comments should be sorted in. In the data object, we'll create a property called sort. Set it to 1. 1 will indicate that the order should be latest to oldest. 2 will be for oldest to latest. We'll use this property to help us determine which direction to sort in the computed property. Back in the sorted comments computed property, add a conditional statement that checks if the this.sort property is equal to 1. 1 represents a descending order, aka latest to oldest. Inside the conditional, return the following: new date b.date posted minus new date a.date posted. A couple of things I want to highlight. We're converting the date from a string to a date object. Storing a JavaScript date object in Firebase is not possible. The date had to be converted into a string for storage. Before making a proper comparison, we need to convert it back into a date object. We're doing this to both parameters. The sort function works by sorting the objects based on the value returned. If the value returned is positive, then A will come first in the array. If 0 is returned, then B and A will stay in their respective indexes. A positive value returned will tell JavaScript to put B first in the array. The calculation we're passing in will result in the objects being sorted from latest to oldest. That'll take care of ordering the comments by descending order. Let's handle the ascending order. We're going to do something similar to what we did in the first conditional block. I'll copy and paste the code below the conditional block. Swap the objects A and B. By flipping the calculation, this will result in the comments being sorted in ascending order, aka oldest to latest. We're finished. This calculation will result in a sorted array. Let's update the template above to use the sorted comments computed property instead of the comments data property. Search for the v-for directive we applied to the list item element. Update the expression to be comment in sorted comments. There's one last thing to do. The user won't be able to toggle the comments because the dropdown isn't tied to the sort data property. On the page, we have a dropdown for choosing the sorting method. By default, the sorting should be latest to oldest. Let's bind the dropdown to a data property to keep track of which sorting arrangement to use. Up in the template, search for the dropdown. There will be a select element with a comment above it that says Sort Comments. Apply the vModel directive to the select element. The value will be sort. After hooking up the dropdown, we can check out the final result in the browser. Save your changes and view the browser. The comments will be in descending order. Toggling the order will change the comments order. This dropdown will continue to work even if we submit a comment. Try submitting a comment while the sorting is in ascending order. The latest comment will appear at the very bottom because the order is from oldest to latest. We've successfully sorted the comments. I'll see you in the next one. In this lecture, we're going to use query parameters to store the comments sorting order. Query parameters are extremely powerful because they allow us to stay on a resource without having to update the entire page. They're mainly used to sort and filter through existing data on the page. But what is a query parameter? A URL consists of a protocol, domain, and path. There's one additional part of the URL that is completely optional called the query string. It's a way to send additional data to the server through the URL. They're mainly used to filter or sort data. The format for a query is pretty simple. You start off by adding a question mark. The question mark denotes that anything after it is a query parameter. Query parameters are key value pairs. If you want to add more query parameters, you need to use the ampersand character to separate the key value pairs. In this example, I'm sending two query parameters. The first is foo with a value of bar, and the second is order with a value of 1. The Vue router supports query parameters. We worked on the sorting feature on the page. We're able to toggle between two values to change the order of comments. If I refresh the page, the sorting order I had previously will be lost. It would be nice if we could save the sorting order. That's entirely possible with query parameters. Query parameters are used by major companies like YouTube, Facebook, and Twitter. For example, if you perform a search on YouTube, you'll be able to refresh the page without performing the search again. The same results will get rendered. YouTube uses query parameters to store the search parameters. We can do something similar for our comments. There are two steps we'll need to take. First, we'll need to update the route whenever the user changes the sorting order. Secondly, we'll need to update the sort data property in our component if the query parameter exists. Open the song component file in your editor. We'll search for the select element for sorting the comment. We use the vModel directive to bind the data property to the input. We want to be able to change the route when the value changes. One approach is to swap the vModel directive with an event listener. While this is possible, we're going to use watchers. We're going to use watchers because it'll require the least changes to our existing solution. It's been a while since we've talked about watchers. A watcher is a function that tracks changes of properties in the component. If a change occurs, we can run a function during the change. In the script block, we'll add the watch property to the components options. The name of the function we define in this object must correspond to the property we want to watch on the component. We want to update the route when the sort property changes. We'll declare a function called sort. We'll accept the first argument. It's the new value for the property we're watching. We'll need it to update the route. We want to add a query parameter to the current route. We can do that by calling the this.router.push function. The push function accepts an object with the changes we'd like to make to the current route. It's the same object you would pass into the to property of the router link component. Previously, we would set the name property followed by the name of the route we'd like to redirect the user to. An example would be the home page. However, we're not forced to redirect the user to a new path. It's safe to remove this property from the object. It doesn't have to exist in the object. We can use the push function to add query parameters to the current URL. In the object, we can define the query property to add query parameters. This property will be an object of query parameters you'd like to set. Query parameters use a key value system. The property's key will be the key for the query and the property's value will be the query's value. The router will take care of converting this from an object to a string that'll be appended to the URL. We'll add a query parameter called sort. Its value will be the new value argument. There aren't rules for how you should name your query parameters. Generally, if you're creating an API, the parameters should have readable and concise names. This is why you will find more descriptive names in REST APIs. If you're using them internally, you may see names shortened to a single letter. For example, YouTube uses the letter V to name its query parameter for a video ID. Not very descriptive, but YouTube doesn't expect people to modify the value. It's something that's handled internally by them. This watcher takes care of the first step. We're able to update the query parameter if the sorting property changes. The next step is to watch out for the query parameter if it already exists on the URL. We'll handle this step in the next lecture. In this lecture, we want to update the sort property whenever there's a query parameter on the initial request. We'll continue working in the song component file. We can use a lifecycle function to check if there's a query parameter in the URL. If there is one, we'll apply the value to the sort data property. In the created lifecycle function, we're going to destructure the this.route.query object for the sort property. At this point in the lifecycle, the component will have been created. Every component is injected with the route object. The properties on this object will have information about the current route data, including the query parameters. It's the perfect time to update the sort data property if there's a query parameter. Make sure that you're typing route and not router. It can be easy to get them mixed up. The router object is a general object for interacting with the router in the application. In contrast, the route object will contain information about the current route. Every route object comes with a query property. It's an object representing the query parameters in the URL. We can use this to grab the sort parameter. We're going to update the sort property, but we're not going to directly assign it to the sort query parameter. We want to make sure the value is valid. The value for the sort can be two possible values, 1 or 2. We'll use a ternary operator to check if the query parameter is a valid value. If it is, we'll set the sort data property to the sort query parameter. Otherwise, we'll leave it at the default value, which is 1. There's one problem with this solution. We're updating the sort property. This update will trigger the watcher for the sort function regardless if the value changed or not. Vue will throw an error at us if we attempt to visit a URL we're already visiting. We want to avoid this error by checking if the new value matches the query parameter. Go back to the sort watcher. We'll add a conditional statement before pushing the query parameter. We'll check if the new value argument is equal to the this.route.query.sort property. If it is, we'll return the function. This condition will prevent the watcher from updating the route if the query parameter already matches the sort value. Let's try testing the application in the browser. On the page for a song, we won't be able to see a query parameter applied to the router because we aren't changing the sorting order for the comments. Despite that, the sorting still works, which is what we want. Let's try changing the sorting order. As we make changes, we'll find that a query parameter has been applied to the URL. With the help of the router, we were able to apply a query parameter easily. The push function did not redirect the user away from the page. It was smart enough to understand we wanted to update the query parameter. Another thing worth noting is how the value was logged in the developer tools. Open the Vue developer tools. Under the Routing History section, we'll find the changes we made to the route. The logger will still log routes even if we're visiting the same route. Fortunately, the router will not reload a component if it's the same component from before. Under the To category, we'll find a new object was added called Query. It'll contain a list of query parameters currently active on the route. We're able to update the query parameter successfully. Let's try refreshing the page to find out with the query parameter still intact. After refreshing the page, the drop-down for sorting the comments has been correctly updated to the query parameter's value. The correct component gets loaded even if the route is slightly different. Query parameters won't affect the path. The router is smart enough to differentiate between the path and query. We previously learned about path parameters for storing values in the URL. It was helpful to use path parameters because we were able to create a dynamic route for various songs. We could have used path parameters to implement this solution, but it's not exactly ideal. Let me explain further. We have two options for storing dynamic values in our URLs. The first is by using query parameters. I'm showing a very simplified example of what a song URL would look like. We're going to use the ID to generate a unique URL. Storing the value in a query parameter is one way to go about it. In the second example, I'm using a path parameter. Rather than storing the ID in a query parameter, we could store the ID in a segment of the path. That's completely possible because the Vue router supports dynamic paths. It's a common feature in most routers. It looks cleaner compared to query parameters. The question is, why is using path parameters a more viable option than query parameters? Technically, either solution works. Vue won't throw an error. Search engines won't have a problem with indexing our site if we use query parameters. It's not so much about errors, but what is considered good standard practice. The general rule of thumb is this. Path parameters are used to retrieve a single or multiple resources. Query parameters are used to filter or sort through data and resources. For sorting comments, using query parameters made sense because we were sorting the comments on the page. For a single song, using a path parameter would make sense because we're retrieving a single resource. By following this practice, you can achieve a more organized route structure. It's a pattern you'll see in most applications. Not every company uses this pattern for one reason or another. Older apps may have adopted a different pattern because the pattern I mentioned is still relatively new. Determining which to use will come with experience. We'll leave it here. We'll continue our work in the next lecture. In this lecture, the very last thing we need to do is to display the number of comments. In the header of the comments section, there is a pair of parentheses with the number of comments for the song. We'll want to make this dynamic. Open the song component file. In the template block, search for the comment count. It can be found under a comment that says comment count. Replace the static number with the expression song.commentCount. The comment count will not accurately represent the number of comments in a song. We're storing the number of comments, but we're not updating the count. Here's what we'll do. We'll update the comment count during the form submission. In the Add Comment function, we'll want to update it after the comment was successfully stored in the database. This happens when we call the Add function on the collection object. After this line, increment the song.commentCount property. We're keeping track of the number of comments in the document. I prefer to keep track of the count rather than making an additional query for the number of comments. That's mostly up for back-end developers to decide, so I wouldn't worry so much about how comment counts are stored. One thing I want you to notice is how I'm incrementing the comment count property. Instead of using a unary operator, we're going to use the addition assignment operator. It's not as short, but it is safer. To better understand, open the link I provide in the resource section of this lecture. ESLint has a rule called no++. It doesn't allow us to use the increment or decrement operators. This restriction is put in place because it can affect the final output of the source code when it gets bundled. There are some examples of how things can go wrong if you use these operators. So what's the workaround? ESLint recommends using the mathematical assignment operators to increment or decrement a value. Here are some examples. This is what we're doing in our function. It may seem nitpicky, but it is a safer solution. We'll follow ESLint's lead. Let's make a request to Firebase to update the number of comments. Back in the function, after updating the comment count property, we'll call the document function on the songs collection object. We need to select the document before we can update it. We're doing this because we're not storing a reference in the component. References are how we can interact with the document in the database. Pass in the ID of the song by using the this.route.params object. After creating a reference, we can call the update function next. This function will accept an object of properties we'd like to update in the document. We don't want to overwrite the whole object or create a new one. The only property to update is the comment count property. We'll set this property to this.song.commentCount. That should do it. Let's save our changes. On the page, submit a comment. The number of comments will increase by 1 after a successful submission. If I were to refresh the page, then the comment count will accurately reflect the current comment count. This proves the changes are persistent in the database. The page we've been working on has made a lot of requests to the database. Compared to other pages in the application, this is the one that has made the most so far. That's perfectly fine. There's no set amount of maximum requests you should make. Anytime you're building an interactive page, you're likely to make more requests than a static one. That's to be expected. Despite making so many requests, our app is still running smoothly. That's thanks to Firebase being able to handle requests reliably. It's time for the most exciting part of the course. We're going to play the music we uploaded into our app. From the looks of the player, you can probably already tell we're going to keep things simple. Before we get into the code, let's go over the process for making the player functional. I've outlined the series of steps we'll be taking to completing the player. First things first, when the play button is clicked on the song page, we'll want to store the data in the state. We've been using a combination of storing the data in the state or components data object. The state is more appropriate because we want the music to persist across all pages in the app, reducing any interruption while the user browses for more music. It wouldn't be a good user experience if a visitor had to stay on a page to listen to music. Storing the music in the state is the best way to approach this because the state is available on all pages and components. After storing the music in the state, we can take care of playing the music to the user. We'll be adding interactivity to the player with functions and events. Towards the end, we'll pause the song after it's finished playing. Even though it's a simple player, you can already see that a lot of work is going to be done to get it to work. I'll be sure to walk you through every step of the way. Playing music in the browser is a relatively easy task. There's even an HTML element that will create a basic player for you if you don't want to create your own. However, if we're going to manage most of the UI, we need to use JavaScript to accomplish that. In the resource section of this lecture, I provide a link to a library called Howler. Howler is a powerful JavaScript library for playing audio files in the browser. Howler provides an API that is lightweight, but flexible enough to make playing audio a breeze. This is what we'll be using to play music. In your editor, switch to the command line. Let's install the package with npm. If the server is running, turn it off. After doing so, run the following command, npm install howler. Let's begin with playing the audio. Open the song component file. This component is where things will start. We want to initiate everything from the moment the user clicks on the play button on the page. Search for the button in the template. On the button, attach the click event with the prevent modifier. The name of the function to execute will be called newSong. This function doesn't exist, but we're not going to define it inside the component. Since the song data will be stored in the state, it would make sense to add the logic for managing the song data in the store. We won't be writing a lot of the logic in the component. Keep in mind, we have an audio player at the bottom of the page. This portion of the page will need access to the audio data. Defining the logic in our store is the best way to go. The newSong function will be an action function. Before we define the action, we will want to pass along the song data property to the action. Next, let's create a new store. We should dedicate a separate store for managing the state of the audio data. Inside the store directory, create a file called player.js. At the top of the file, import the defineStore function from the Pinia package. Afterward, export this function under the default namespace. Set the ID to player. We can start configuring the store by passing in an object as the second argument. Inside the object, add the actions property. Define the new song function as an asynchronous function. This function should accept the song data. The action is not available in the component because we're not mapping it. Go back to the song component file. We're going to map the action. In the script block, we're already importing the Pinia package. Update the import statement to include the map actions function. While we're here, import the player store. With the function imported, we can call it inside the methods object with the spread operator. We're using the spread operator to merge the functions mapped from the store with the methods already in the object. Let's pass in the player store as the first argument to the function. The map actions function expects us to pass in an array of actions we'd like to map. We want to map the new song action function. That'll add the action to the component. Head back to the store. Inside the object, add the state function. Next, define a state property called currentSong with an initial value of an empty object. The last step is to update this property with the song data. Inside the body of the new song action function, set the currentSong property to the song argument. We're finished. It's been a while since we've worked with the state. Don't worry, I'll recap everything we did. For now, let's try testing our work. In the browser, refresh the page. Before pressing play, open the View Developer Tools. We want to check if the state updates when we click the play button on the page. Press the play button for any song you want. After clicking the button, we can verify the data was stored in the state by viewing the Pinia tab in the Developer Tools. If we look at the Player Store, the current song state property has been updated with the song data. Now that the song is saved in the state, we can begin to play the music. Before we do that, let me recap what we did. In the song component file, we added a click event listener to the play button. When the event is emitted, a function called newSong will run. We're passing on the song data to the function. Down below, we imported the map actions function. It'll help us map the new song function from the store to the component. The song data will be stored in the state. It makes sense to define the function that will manipulate the state in the store rather than in the component. That's why we're choosing to define it as an action. The function we're mapping is called newSong. From within the action function, the song data gets saved in the current song state property. It's a pretty straightforward process. We can proceed to the next step, which is to play the song using Howler. In this lecture, we're going to play the song with Howler. We've already installed Howler. To use Howler, we'll need to import it into the store file. Open this file in your editor. With the other import statements, add the following. Import Howl from Howler. The Howl object will be used to create a new audio object. We'll use it to load the audio file and control it. Howler will create an object with methods and properties when we create a new audio object. We'll want to store this because we'll be able to pause and play the audio at any moment. The best place to store this object is in the state. That will make it accessible throughout the application. Inside the state, add a property called Sounds. We'll set it to an empty object. We'll create a new instance of the Howl object when a song is added to the state. We can write this logic from the action. Scroll to the New Song action. Inside it, create a new instance of the Howl object. assign the value returned to the sound state property. Once again, we're storing the new instance of the Howl object because we want to be able to interact with the audio anywhere in our application. If we want to begin playing audio, we need to pass in a few strings to the new instance. That can be done by passing in an object. In the new object, the first property we'll want to set is the source. This property will be an array of audio files we'd like to play. We're not interested in having multiple audio files. The values in the array must be the URL to the audio file. For our case, the URL can be accessed from the song object passed into the function. Inside the array, add the song.url property. The URL property contains the full HTTP URL to the audio file. We stored the URL when we uploaded the audio file to the storage. Firebase generated this URL for us. The next property to set is the HTML5 property. By default, Howler will request the audio file with an AJAX request. However, that will result in an origin policy error because the audio file is stored in an external location. By setting this property to true, the library will switch to the HTML5 audio API to retrieve audio files. The audio file will be loaded into the browser, but it will not begin playing. We just initialized the object. To play the song, we need to call a function called play. We'll play the music in the action function. After storing the instance, we can call the this.sound.play function. Let's give things a test. Go to your browser and view an individual song. Press the play button. After pressing the play button, you should begin to hear the audio play. Great! We've successfully played the audio by using Howler. Unfortunately, we don't have a way of pausing the song besides refreshing the page. Let's make the player at the bottom interactive. We'll take care of this in the next lecture. In this lecture, we're going to toggle the audio with the player. First, we're going to move the audio player into a separate component. Open the app component file in your editor. In the template block, search for the player. Above it, there's a comment that says player to make it easier to find. It would be a good idea to put the player into a separate component. Let's do that now. Inside the components directory, create a new file called player.view. Scaffold the template and script blocks. Set the name property in the component to player. We'll move the HTML from the app component to the newly created component. In the app component, cut the player template. Then, we'll paste it into the player component's template block. This component will need to be registered. We'll handle that next. Back in the app component, import the player component. The name of the component object is called AppPlayer. We're using the app prefix to prevent name collisions. In the app component, we'll add the app player to the list of components in the component property. With the component registered, let's load it in the area where we previously removed it. We'll switch to the browser to check if the player still loads. As expected, it does. Great! We can begin to toggle the song both audibly and visibly. The icon in the play button will need to change depending on if the song is playing or not. We're using Font Awesome to create the icons. There's a pause icon that we can use. To tackle this, we're going to create a function that will toggle the audio controlled by Howler. Howler makes the process very easy. We're going to create the function in the store because the Howler object is stored in the state. Anything that affects the state should be defined as an action function. Let's go back to our editors. Inside the store file, define an asynchronous action function called toggleAudio. At the moment, we're not entirely sure if Howler is even ready. If there is no how object, we can't toggle the audio. Initially, our app will load the sound property as an empty object. It will be a good idea to check if the object is a how object or a plain empty object. Inside the action, create a conditional statement that'll check if the sound.playing property returns false. The condition we're using is checking if a function called playing is defined in the object. It's a function that's available on the how object. We're checking if the function exists. If it does, we know there's an existing how object. Otherwise, we're going to return the function because there isn't an audio file to toggle. After the conditional statement, it's safe to assume the sound state property is a how object. We can toggle the audio. First, we need to know if the audio is playing. By knowing that, we will be able to pause or play the audio properly. Create a conditional statement that calls the playing function. We have two conditional statements that are similar. The difference between them is that in the second conditional statement, we're invoking the playing function. We're omitting the parentheses in the first conditional statement. This will mean the playing function doesn't get invoked. JavaScript will see this as us checking if the function exists on the object. The playing function, when called, will check if the audio is playing. It'll return a Boolean value. If this returns true, we'll pause the audio. Inside the conditional block, call the function sound.pause. If you're curious about the available functions on the how object, they can be found on Howler's documentation. Each instance comes with the functions we're using. As you would suspect, the pause function will pause the audio. If the music's already paused, we'll want to play it. Create an else block where the play function will be called. The action function is ready. Let's map it to the player component so that we can call it when the play pause button is clicked. In the player component file, import the map actions function from the Pinia module. Next, import the player store. We'll create the methods object. Inside of it, we'll call the map actions function with the spread operator. We want to map the toggle audio function. We want the function to be called when the play button is clicked. In the template block, search for the button. It'll be under a comment that says play pause button. Attach the click event with the prevent modifier. The method we'll call if it's clicked is the toggle audio function. Let's give things a test. Play any song you want. After a few seconds, you should be able to pause or play the audio by pressing the play button on the player. The icon doesn't correctly update. We'll fix that soon, but first, make sure the audio is pausing when you press the button. Once you've confirmed that, let's move on to updating the icon. The icon in the button will be based on if the audio is playing or paused. We can use the playing function to help us out with that. Here's what we'll do. We'll create a getter function that will return the value returned by the playing function. A getter function is perfect because we'll be able to use it in any component in the application. Go back to the store file in your editor. First, we must add the getters object for storing our getter functions. Inside it, we'll add a getter function called playing. Getter functions are provided the state object as the first parameter. We'll accept it because we want to call the playing function on the sound state property. Before we call the playing function, we want to check if it exists. Create a conditional statement that checks if the state.sound.playing function is defined. If it is, return the value returned by the function. If the function isn't defined, it's safe to assume that there isn't audio playing. After the conditional statement, we can return false. The next thing we'll do is map the getter function to the player component. We won't be able to call it if it isn't mapped. Switch to the player component file. In the script block, add the map state function to the import statement. As a reminder, the map state function can map state properties and getter functions. Despite the name, it's not exclusive to state properties. Getters are the equivalent of computed properties for the state. Create the computed object in the component. Inside the object, we'll call the map getters function inside of it with the spread operator. Map the playing getter function. After mapping the function, it can be used to update the icon. In the template block, go back to the button we added the event listener to. Inside of the button will be an icon. We're using Font Awesome to create the icon. If we want to change the icon, we'll need to bind the class attribute on the element. We're binding the attribute because we want the classes to be dynamic. Dynamic classes can be added by using object syntax. At the moment, the FA-Play class is statically loaded into the class attribute. Remove it from the class attribute and move it over to our binding as a property. The value for this property will be the playing getter function. We want to check if the function returns false. If it is false, then the audio is paused. The play icon should be displayed to indicate that the audio can be played. The next icon we'll want to add is the pause icon. The name of the class for the pause icon in Font Awesome is called FA-Pause. The value for this will be the playing function, but this time we want to check if it returns true. If it returns true, then we want to display a pause icon to let the user know they can pause the audio. Switch back to the browser to test if the icon toggles correctly. By creating a getter function, we can update the UI accordingly. The second half of the player is the progress bar. We'll work on this in the next lecture. In this lecture, we're going to modify the player to output the current audio duration and position. On the left of the audio player is the current position of the audio. On the right, we have the duration of the audio. Howler provides functions for retrieving both values. The challenge will be updating the current position of the audio. We're going to store the duration and position values as state properties. Open the store file in your editor. We're going to add the properties called seek and duration to the state. Both will be set to 00:00 by default. The current position is called seek in Howler. We'll use the same name for consistency. Both properties will have the same values to show that there's currently no audio present. Alternatively, you could choose to have an empty string depending on what you would like to achieve visually. The next step is to display these state properties in the template. Open the player component file. We're going to map the state to create getter functions. We'll call the map state function inside the computed object with the spread operator. The state properties we'll want to map are the duration and seek properties. We can begin to tie the state properties to the template. Search for the span tag with the class player current time. This element can be found under a comment that says current position. Replace the static inner text with the expression seek. The current time will be displayed on the left side of the progress bar. On the right, we'll have the duration of the audio. Not far below, you'll find a span tag with the class player duration. It'll be under a comment that says duration. Replace the static duration with the expression duration. The template is ready. The last thing we need to do is update the state properties whenever a new song starts playing. We'll use actions and mutations to make these updates. Howler comes with an event that gets emitted when the audio starts playing. We'll want to listen for that event. back in the store file, go to the New Song Action function. We want to listen for the event after the mutation has been committed and the play function has been called. At these 2 points, it's safe to assume there's an instance of Howler available with the audio playing. Using the sound.on function, listen for an event called play. In the second argument of the on function, pass in an arrow function to handle the event. Inside the function, call the requestAnimationFrame function. The requestAnimationFrame function we're using will execute a function passed into it. It's similar to the setInterval function, except the function gets called before the next frame gets painted onto the screen. It's perfect for updating the duration and seek state properties. Pass in a function called this.progress. We're going to create a separate action function for updating the progress of the current song. We could have added the logic to the New Song Action function, but I want to keep things organized. One action function for adding a new song to the player and another for updating the progress. Define the progress function inside the actions object. The progress function will perform 2 tasks. First, it'll commit a mutation for the 2 state properties used in the player. The second task is to dispatch the progress function again. The requestAnimationFrame function is not recursive. It'll only execute once. If we want recursion, then we'll need to dispatch the progress action again. First, we'll update the seek state property. We'll set it to the sound.seek function. The seek function will return the current position of the audio being played. Next, set the duration state property to the sound.duration function. That'll set the duration property to the current duration of the song. Let's move on to the next step. The code we've written is not recursive because the requestAnimationFrame function does not repeatedly call the callback function. We'll need to dispatch the action again from within itself. If we don't, the seek state property will never reflect the current position of the audio. Before we do that, we need to make sure the song is currently playing. If it's not, then there isn't a point in continuously calling the function. In the action, create a conditional statement to check if the state.sounds.playing function returns true. If it is, we can call the requestAnimationFrame function to dispatch the progress action. We don't have to worry about calling the function if the audio is paused. The event listener we added in the New Song Action function will dispatch the progress function if the song gets paused and then played again. Switch to the browser. Play a song in the app. The player will display the current position and duration, but the format is incorrect. The functions we called to retrieve these values will return the time in seconds. We'll need to create a function that'll correctly format the time to what we desire. We'll take care of this formatting issue in the next lecture. In this lecture, we're going to properly format the time in the audio player. This would be a perfect time to create a utility function. Sometimes you'll want to create functions that can help you perform basic operations such as formatting. We're going to create a utility function for formatting the time. In the includes directory, create a file called helper.js. Inside the file, export an object. In the object, we'll add a function called formatTime. The purpose of the helper file is to store utility functions for assisting us with basic tasks. The first utility function we'll create will be called formatTime. The formatTime function will accept the time in seconds. It'll return the time formatted. The parameter for the time will be called time. The format we'll use will be simple. We'll output the number of minutes and seconds. A colon will separate the two numbers. It's the usual format you'll see for most audio players. First, we need to calculate how many minutes are in the value. Create a variable called minutes. We'll set it to the following: math.floor_num divided by 60 or 0. Calculating the number of minutes is straightforward. It's dividing the number of seconds by 60. We're wrapping the arithmetic operation with the math.floor function because we don't want decimal values. This function will round the number down, which is beneficial for us. We don't want to make a song appear longer than it is. If the calculation results in undefined or NaN, then we'll set it to 0. Not every song will be evenly divisible by 60. We'll need to grab the leftover seconds. We'll create a variable called seconds. Set it to the following: math.round_num minus minutes times 60 or 0. We're trying to calculate how many seconds are left over. This calculation will give us the number of minutes in seconds. We subtract the total of seconds with the result. The final value will be the leftover seconds in the song. If a result can't be reached, then we'll set it to 0. The final result is wrapped with the math.round function to prevent decimal values from appearing in the time. We have both values in hand. The last step is to return the formatted result. Return the following with a literal string: minutes, seconds, less than, 10, 0, empty string, seconds. Let me break down what's going on in the function. In the first half, we display the number of minutes in the song. There's nothing trivial about it, just the value, and that's it. Things get tricky when we want to start displaying the number because we want to display a 0 before the number if the number is less than 10. This is how most timers will display seconds. A ternary operator is used to check if the seconds variable is less than 10. If it is, we'll add a 0 before adding the number of seconds. Otherwise, nothing is added. Once that's done, we add the number of seconds. The function is ready. Let's import it inside the store file so that we can use it. We'll call the import helper. The path to the file is @/includes/helper. Next, scroll to the progress function. Wrap both functions that retrieve the time with the helper.formatTime function. Let's give the app one more test. By pressing the play button, we will see that time is appropriately formatted. Great! The last part is to make the progress bar functional. We'll start this task in the next lecture. In this lecture, we're going to add movement to the progress bar in the player. Progress bars are another visual feature that comes with audio players. Our player will be no different. There are two elements we'll want to update while the song is playing. There's the green bar, and then there's the little ball attached to the end of the bar. Both will need to be animated. We'll make the green bar move by its width. As for the ball, it's an element using absolute positioning. Its left CSS property will need to be changed. The great thing about this is that both the bar and ball can use the same value for moving them. You'll see what I mean in a moment. Above the progress bar is the name of the song and the user who uploaded it. We're going to make this part dynamic by mapping the state property that holds this data to the component. First, let's create a state property for storing the position of the elements we'll be moving. Go ahead and open the store file in your editor. Inside the store file, we'll create a state property called player progress with an initial value of 0%. We're using percentages because the width and left CSS properties will accept the percent unit. This way, we don't need to store two different values that accomplish the same thing. Let's switch to the player component file. We're going to map the player progress state property to the component. In the computed object, we're already mapping the duration and seek state properties to the component. we'll add on to the list by adding the player progress state property. Afterward, we'll want to bind this property to the progress bar elements. The elements for the audio progress bar can be found under a comment that says scrub. Nested inside this element, there are two more comments that say player ball and player progress bar. The ball is positioned using absolute positioning. We need to change the left property to move it. On it, bind the style attribute with object syntax. Set the left property to the player progress state property. We're going to copy this over to the player progress bar element. This is for the bar itself. Instead of changing the left position, we'll want to change its width. After making those changes, switch to the browser. Both the button and bar are positioned at the very beginning of the player. The bar won't be visible because it'll have a width of 0%. The next step is to update the player progress state property while the audio is playing. This update will result in the progress bar moving. Back in the player file, search for the progress function. Within this action function, we're updating the duration and seek properties. Let's update the player progress property to a template string. Inside this string, divide the values returned by the seek and duration functions. The result will be a numeric value between 0 and 1. To get a more accurate percentage, we'll need to multiply it by 100. Then, we'll add the percent symbol. Great, we're almost finished. The next thing we'll do is map the name of the song and uploader to the player component. Switch back to the player component file in your editor. The data for the song can be found in the current song state property. It's not mapped to the component at the moment. It'll need to be mapped if we want to display that information. In the computed object, we're mapping the state already. We'll add on to the list by mapping the current song state property. This property is where we stored the information from the database. We'll update the template to output the information we need. In the template block, search for a comment that says track info. This tag is where the song info is outputted. We'll start by adding the vif directive to the surrounding div element. The element shouldn't be viewable if the user hasn't selected a song to play. We'll want to hide the element. The condition for the vif directive will be current song.modified name. In some cases, you will want to use the length property to check if an object is empty. However, we're not doing that here. That's because the length property isn't completely reliable with computed properties, especially for objects. I find it better to check if a property is defined in the object. By default, the current song object is empty, so it won't have this property. It's the perfect thing to check for. If the modified name property is defined, we know that the user selected a song to play. We can move on to displaying the information. There's a span element with the class of song title. Replace the inner text with the expression current song.modified name. Below it is a span tag with the class of song artist. We'll replace the inner text with the expression current song.displayname. Once you've done that, save your changes. Then go to your browser and test the player. The bar and ball move while the audio is playing. You can even toggle the audio to check if they stop or move. In addition, the name of the song and artist appears above the progress bar as we want it. Congrats! We have a fully functioning player. It's a very simple one. We could add a lot more features to the player, but I don't want to get too repetitive. There's one last issue I want to resolve. I'm going to quickly navigate to a song's page. If I were to press the play button on the player and then press the play button on the page, you'd notice that we get multiple audio sources playing at once. We don't want this. If the play button on the page gets pressed, we want to pause the current audio and destroy the instance. After the instance has been destroyed, we can start a new one. That will stop the application from playing multiple audio sources. Back in the editor, go to the New Song Action function. At the beginning of the function, we'll want to check if the sound state property is an instance of the howl object. We'll create a conditional statement to handle this check. In the conditional statement, we're using the instance of operator to help us check if the sound object is an instance of the howl object. If it is, we can invoke a function called unload. The unload function will pause the current audio. It'll also delete the instance and remove it from memory. This is beneficial to us because we don't have to worry about Howler causing memory leaking issues. After making that change, go ahead with testing the player. If I press the play button twice, we should only hear one song play. The previous audio source will have been destroyed. Fantastic! We've got a working player. We're able to play and toggle the audio. The next step in our journey is to change the audio's current position if the user clicks on the timeline. We'll tackle this issue in the next lecture. In this lecture, we're going to learn how to change the audio position if the timeline is clicked. Users will be able to play music without a problem. In some cases, they may want to jump to a specific spot in the audio. This feature is common in most audio players. We can replicate this feature by listening for clicks on the timeline. If we detect a click, we'll update the audio position to move to the location they clicked on. The entire process is going to be tricky because we need to figure out where to move the audio position. Let's dive into the code and find out how we can perform this task. We're going to be working in the player component file. The first step is to listen for click events on the player. In the template, search for a comment that says scrub container. You should be able to find it somewhere in the middle. The scrub container element contains the entire timeline. We want to listen for clicks, especially on this element. We don't want to move the audio if the user clicks somewhere else on the player. We'll add the click event listener to the element with the prevent modifier. The name of the function to run will be called updateSeek. We're going to define the function in the store as an action function. The reason we're going to outsource the function to the store is because we'll be changing the state. Anytime we have logic for mutating the state, we should put the logic in the store. Open the store file in your editor. In the action section, we'll define the updateSeek function. The name of the function we're using is called updateSeek. We're using the word seek because Howler uses this name to describe the current position of the audio. Let's go back to the player component file. Scroll down to the script block. In the methods option, we're mapping the actions by using the map actions function. We'll add on to the array of functions we want to map by including the updateSeek action function. Great. We can focus on writing the action function. The next step is to figure out where to move the audio position. We're going to need some information about the event. Luckily, Vue will always pass on the event to the function handler. Let's accept the event as an argument called event. The click event we have in the player component file directly calls the action function. By default, Vue will always pass the event object onto the function it called when an event is emitted. We'll need it to help us calculate where to move the audio position. Inside the function, we're going to start by creating a conditional statement. The condition will check if the state.sounds.playing property exists. If it doesn't, we'll return the function. This conditional statement is an extra precaution. it doesn't make sense to move the ball on the timeline visually. If there is a song being played, we'll begin updating the state. There are two things we'll want to update. The first is the ball on the timeline. We want to provide a visual cue for letting the user know their audio has been moved. This includes the time on the left side of the player. The second is the audio's position. The user should audibly hear the song change to a different position. These changes will be based on where the user has clicked on the timeline. We'll need to grab where they clicked on the timeline. Below the conditional statement, we'll declare a variable called clickX. Its value will be the event.clientX property. We have access to information about the event that was emitted. One of the properties we have access to is the clientX property. This property will represent the X coordinate of the click. We're interested in moving the ball horizontally. Its vertical position can stay the same. However, this value is not reliable. I'm going to add a comment to help you better understand why it's not suitable. The timeline we have in the player does not take up the entire width of the page. If the user clicks in the middle of the timeline, the clientX property will not represent the coordinate relative to the player. Instead, it'll be relative to the document. For example, let's say the document's width is 2000 pixels. The timeline is 1000 pixels. If we click in the middle of the timeline, we would expect the clientX property to be 500. The browser will return 1000. The reason it returns 1000 is because the click is registered relative to the document. The center of the player is also the center of the document. The X coordinate for the center of the document is 1000. This value is what will be returned. If we want to get the coordinate relative to the timeline, we'll need to get the distance from the left side of the document to the left side of the timeline. For example, let's say the distance was 500 pixels. We can subtract the click's X coordinate from the distance. This calculation would result in the final result of 500, which is what we want. Above the variable, we're going to destructure the object returned by the event.currentTarget.getBoundingClientRect function. The function we're using will return information about the current element's coordinates and dimensions. We're using a special called currentTarget. It's not a property that's used often, but is especially important in our case. In JavaScript, events can be emitted from children elements with parent elements that have event listeners. The element that triggers the event will be stored in a property called target. This property can either be the element that was clicked on the element that has the event listener. We always want to grab the element with the event listener. If we were returned the dimensions and coordinates of children elements, this might cause the player to play audio from the wrong position. An alternative property we can use is the currentTarget property. It'll always return the same element, which is the element where the event listener is added to. On this element, we're grabbing the coordinates and dimensions with this function. The property we care about is called X. We'll destructure it from the object returned. The X property represents the distance from the left side of the document to the left side of the player. We can subtract this from the clientX property to get the correct coordinate of where the user clicked on the timeline. We've got the coordinate, but it's not exactly what we need. We need the seconds. We're going to use the coordinate to figure out the percentage of where the user clicked. Then, we'll multiply the percentage by the duration. This calculation will give us the position we should move the audio to. We'll create a variable called percentage. Its value will be the clickX variable divided by the width of the player. The width of the player doesn't exist in our function. We can grab it from the getBoundingClientRect function. We'll destructure the width property from this object. The last thing we'll do is create a variable called seconds. Its value will be the sound.duration function multiplied by the percentage variable. We've successfully grabbed the seconds. we're going to tell Howler to update the audio's position by calling the sound.seek function. Previously, we used the seek function to get the current position. It can also be used to update the position. We'll pass in the seconds variable to tell it to update the position. One last thing, the audio player will not reflect the audio's current position. We should run the progress action function after changing the audio position. We don't need to rewrite the code for visually changing the timeline. We can reuse this action. At the bottom of the function, we'll listen for an event called seek by using the sound.once function. The seek function we're calling will temporarily pause the audio. We're continuously dispatching the progress action within itself. It may notice the audio isn't playing anymore. If that's the case, the action will stop dispatching itself. We don't want this to happen because we know that the audio needs to change position. We can start the loop again by dispatching the action after the audio has changed its position. We're using a function called once. The once function will listen for an event. If the event is emitted, it'll run the callback function passed into it. This callback function will only run once. The name of the event we're listening to is called seek. Howler will emit this event when the audio has officially changed position. At this point, the audio will start playing again. Let's pass in the this.progress function. We're finished. Let's try testing the application in the browser. In your browser, try playing an audio file. While it's playing, click on the timeline to change the current position. The player and audio update correctly. It's the exact behavior we were looking for. We've completed the player. There's so much more we can do, but we'll keep it minimal. I want to shift our focus back to view-related topics. In this lecture, we're going to create links to the comments section of a song. There may be times where you'll want to jump to a specific action on a page. We learned that hash fragments could be used to force the browser to jump to a section of the page without refreshing it. The router library supports hash fragments out of the box. We can instruct the router to redirect the user to a specific section on a page. On the home page, we're displaying a list of songs uploaded to the application. On the right of every song are the number of comments. We're going to convert this part of the list item to a link. It'll redirect the user to the song, but take them to the comments section. There are two things we'll need to do. First, we need to generate a link to the page with the hash fragment. The router will not be able to scroll the browser to the section if the hash fragment is not available. Secondly, we'll need to scroll the page to the section. The router will help us with this. Open the Song Item component in your editor. This component is where we wrote the code for creating list items. In the template block, search for a span tag with the class of comments. We're going to make the span tag clickable. It should redirect the user to the page for the song and jump right to the comments section. We will wrap the span tag with the router link component. The router link component will attempt to wrap the element with an anchor element. To prevent that, we need to add the custom property. The custom property will tell the router to give us complete control over the behavior of the component. By adding this property, we need to tell the router when to redirect the user. We'll get to that in a moment. First, let's add the to property on the component. We can save time by copying the to property we have in the first router link component over to the link for the comments. The properties will be similar because we're ultimately trying to link the user to the same page. The difference is that the comments link will take the user to the comments section of the page. We can add a hash fragment to the link by adding a property called hash to the object we're passing into the to property. The value for this property must be the ID of the element we'd like the browser to jump to. It must come with the hash. We're going to pass in hash comments. One last thing, we will add the vslot directive to the component. We're going to destructure the object for a function called navigate. Since we've added the custom property, we need to tell the router when to navigate to a different page. The navigate function we're destructuring will help us with that. We can run this function to tell the router to proceed with the request. We will add the click event listener on the span element. We will run the navigate function if this element is clicked. The router link component is ready. Currently, there isn't a section with this ID. We'll need to add it. Open the song component file. This component is the component we use to handle the page content for an individual song. Inside the template block, there are two sections. The second section is the container for the comments. On the section element surrounding the comments, add the ID attribute. Set it to comments. The router will be able to instruct the browser to move the viewing area to the section by scrolling to it. Let's give this a test. In the browser, open the home page of the app. Click on any of the comment links in the list. We will be redirected to the song. If we look at the URL, the comments hash fragment was added to the end. The router link component was capable of generating this link. It may not look like it, but we were taken to the section. If you'd like to double check, then I recommend opening the developer tools to shorten the window's height. After opening it, we can test if the router takes us to the section. Great, it's taking us to the section thanks to hash fragments. It's great that Vue can cover scenarios like this to help us provide a better user experience. In this lecture, we're going to learn how to add transitions to our routes. In theory, the job of the router is to swap components when a different path is visited. Components are constantly leaving and entering the page. We'll be able to apply transitions to the components that are being swapped by the router. Open the app component file in your editor. In the template block, have a component called router view. The Vue router registers this component. Its job is to load the component we registered with the path that's currently being visited. If we want to be able to apply transitions, we need to add a slot property. We will add the vslot directive to the router view component. We are going to destructure the slot properties for an object called component. Make sure the name of the object has a capital C. The reason we are grabbing a slot property is because we need access to the components that are being swapped. The Vue router does a lot of things behind the scenes when switching routes. By grabbing the component from the router view component, we are telling the router we want to control the process of swapping components. This will allow us to apply a transition to the components. Inside the router view component, we are going to add the component component. The component component can be considered a ghost component. It's a component registered by Vue. It doesn't render anything on its own. We can use it for loading a component dynamically. The component it'll render is the component we pass into the is property. We'll bind this property to this component. Next, we'll pass in the component slot property. The component component will render whatever component is provided by the router view component. Our original goal was to apply a transition. We will wrap this component with the transition component. We can add a transition like normally. We don't have to learn anything new for applying transitions to routes. For this example, we're going to recreate the fade animation we created in the section where we discussed animations and transitions. We'll set the name property to fade. The next thing we'll need to do is create the classes. To save some time, I'm going to add them to the component quickly. I'll see you in a moment. In the app component, I've added the style block. There are 3 classes I'm defining. This will create the fade effect for transitioning the page. Pause the video so you can copy these styles. The components shouldn't transition at the same time. We want the component leaving the page to transition first. Afterward, the new component for the route should enter the page. We can achieve this behavior by setting the mode property on the router view component to OutIn. There's one last step we need to take. The transitions won't work if the components have multiple root elements. We'll receive an error if we attempt to transition a component with this structure. In the Views directory, open the Home and Song component files. Both components have multiple root elements. We're going to wrap the templates of both components with the main tag. This should prevent an error from being thrown. Go ahead with opening the application in the browser. Starting from the home page, I can navigate anywhere I want without a problem. The main difference from before is that the transitions will play in between navigations. This is how you can apply transitions to routes. The process is simple thanks to the APIs provided by Vue. Congrats! We're finished with the app. It took a while, but it was well worth the effort. Our journey with Vue isn't finished, however. There are a few more topics we'll need to discuss. We're going to continue working on the app to give it a more polished feel. Take a break before proceeding. Once your mind is fresh, go ahead to the next section.